This is Bob Capetta from the College of the Florida Keys, and this lesson is on rationalizing denominators. So generally speaking, we do not like to have denominators in that have radicals. So if I have something like 4 over the square root of 2, we see a radical downstairs. We want to do something so that there is no radical downstairs. So we need to rationalize it, turn it into a rational number. I'm going to multiply top and bottom by the same number, multiply the bottom by root 2 and the top by root 2. That makes the top 4 root 2. That makes the bottom root 2 times 2, which of course the 2 comes out and becomes 2, so we get 4 root 2 over 2. Now this 2 and that 2 do not divide out, but the 4 and the 2 can. So 2 goes into 2 once, 2 goes into 4 twice. So we get 2 root 2 over 1, or 2 root 2. So notice we started with 4 over root 2. We wind up with 2 root 2. If I have a question like this, like the square root of 7 over 3, we have to realize that can be written as square root of 7 over square root of 3. Now there's a radical downstairs. We do not want to have radicals in the bottom. We're going to multiply top and bottom by the same number, this time square root of 3. Upstairs root 7 times root 3. Downstairs root 3 times root 3. So upstairs that's root 21. Downstairs root 3 times 3, it's a pair of 3s. The 3 comes out and we get root 21 over 3. So we have to ask ourselves, what do we multiply by so that we no longer have a radical in the denominator? If I have root 2a over 5b, and note, assume all variables are positive. So that will be our assumption for all of the problems in this lesson. Because if b is negative, I have a problem. Square root of b, square root of a negative number could be a problem. If a is negative, square root of a could be a problem. If b is 0, that could be a problem. So just for the sake of keeping things clean, we'll go ahead and assume that the variables are going to be positive. So I have the square root of 2a over the square root of 5b. Yes, I have radicals downstairs. I have root 5 in a sense, and I have root b in a sense. So I'm going to multiply top and bottom by the same thing. I have a 5. I need another 5, so I'm going to need to multiply by root 5. I have a b. I need another b. I'll multiply by root 5b. So upstairs, root 2a times root 5b is root 10ab. Downstairs, I have root 5b, root 5b, which is root 5bb. And you'll notice 5 comes out, bb comes out. And we get root 10ab over 5b. Now, do not try to divide these out. Under the square root, the root 10 and the 5 do not divide out. The b under the square root and the b down here do not divide out. And my answer is root 10a over 5b. These get more interesting, though, if we go to different roots other than square roots. So if I look at the cube root of 7 over 25, how is that going to work? Well, that's the cube root of 7 over the cube root of 25. And I need to figure out, what do I need to multiply on the bottom so that there is no radical there? I'll do another equal first. Cube root of 7 over cube root of 5 times 5. So you'll notice I already have 2 5s downstairs. I have 5 times 5 downstairs. But what else do I need to zap the cube root? I need 3 5s. So I've got to multiply the bottom by cube root of 5, multiply the top by cube root of 5. So on the top now, I have cube root of 7 times 5, cube root of 35. On the bottom, I have cube root of 5 times 5 times 5. And I need 3 of them to come out. So my answer would be cube root of 35 over 5. Next up, let's take a look at the cube root of 1/20. So we want to get rid of the cube root downstairs. So that's the cube root of 1 over the cube root of 20, which is 1 over the cube root of 20 of 2 times 5. Now I've got to multiply the same thing on the top and the bottom. I have 2 2's, I need 3 of them, so I need 1 more 2. So on the bottom, we'll multiply by cube root of 2, and on the top, multiply by the cube root of 2. I have 1 5, but I need 3 of them, so multiply by 2 more, times 5 times 5, times 5 times 5. So on top, we have the cube root of 2 times 5, which is 50. On the bottom, we have the cube root of 555. So the 2 comes out and the 5 comes out. So this equals the cube root of 50 over 2 comes out and 5 comes out over 2 times 5. 2 times 5, of course, is 10. So we get the cube root of 50 over 10. Do not think you can divide out the 50 and the 10, though. The cube root of 50 is under the radical, the 10 is not. So there's no way for us to simplify that easily. Okay, let's continue with the cube root discussion. If I have the cube root of a over the cube root of 9x, it'll be a very similar problem to the one that we just did, except we have variables this time. Cube root of a, cube root of 9, 3 times 3. X is x. Multiply top and bottom by the same thing. I have 2 3's, I need 1 more. So multiply the bottom by cube root of x, multiply the top by cube root of x, 3. Cube root of 3 on the bottom, cube root of 3 on the top will now give me 3 3's on the bottom. I have 1 x, I need 2 more to get out of the cube root. So x. Upstairs, I have the cube root of 3ax squared. Downstairs, I have the cube root of 333 x. So a 3 comes out and an x comes out, and my answer will be the cube root of 3ax squared over 3x. And again, do not try to divide out the 3's or the x's. They do not divide out. Now, let's do one more sort of in this same line, except I'm going to kick it up to a 5th root. If I have 3x over the 5th root of 8x squared y cubed, I need 5 now to leave a 5th root. So I need to do my factoring and see how many more I need. So I have 3x over the 5th root of 8, which is 2 times 2 times 2. X squared, which is xx. Y cubed, which is y. Now I know I need to have 5 to break out of a 5th root. I have 1, 2, 3 2's, so I need 2 more. 5th root of 2 times 2 on the bottom. 5th root of 2 times 2 on the top. I have 2 x's, I need 5, so I need 3 more. 1, 2, 3 on the bottom. 1, 2, 3 on the top. I have 3 y's on the bottom, I need 2 more. Y on the bottom, y on the top. So upstairs now, what do we have? We have 3x times the 5th root. 2 times 2 is 4. X is x cubed. Y is y squared over 2, 2, 2, 2, 2. So 5 2's. X, 5 x's. And 5 y's. So upstairs we have 3x times the fifth root of 4x cubed y squared. Downstairs, we have a 2 that comes out, an x that comes out, and a y that comes out. But this is one case when you can divide out. The x upstairs and the x downstairs are both outside the radicals. So that my final answer will be 3 times the fifth root of 4x cubed y squared, all divided by 2y. That will be our final answer. Now, all the ones we've done so far have had monomial denominators, single term polynomials on the bottom. If we have things with multiple terms, it's a bit more challenging. So let's take a look. The next example I'm going to get is 3 over x plus the square root of 7. So we have a binomial downstairs. It has a radical. We're going to multiply top and bottom by the same thing. What do we multiply the top and bottom by? The answer is the conjugate. Multiply top and bottom by the conjugate. The conjugate requires you to change the sign. So x plus root 7, its conjugate is x minus root 7. So upstairs we have 3 times x minus root 7. Downstairs we have x plus root 7 times x minus root 7. Now remember, our goal was to get rid of the radicals downstairs, but we still have radicals downstairs. We have to multiply out x plus root 7 times x minus root 7. So let's do that. We have x plus root 7. We have x minus root 7. X times x is x squared. Negative root 7 times x is negative root 7x. Positive root 7 times x is positive root 7x. Negative times positive, negative root 7, root 49 is negative 7. So if we add all this stuff up, you'll notice the negative root x and the 7x and the positive root 7x go away. And all that's left is x squared minus 7. That's what's on the bottom. So what's on the top? 3x minus 3 root 7. All over what? All over x squared minus 7. So let's take a look at another one in that same sort of vein. Let's look at root 7 plus 4 divided by 3 minus 2 root 5. Our goal is to rationalize the denominator, so we do not want to have the square root of 5 downstairs. So we're going to multiply top and bottom by the conjugate. That requires you to rewrite this with changing the sign in the middle. So root 7 plus 4 over 3 minus 2 root 5. Multiply top and bottom by the conjugate, which is 3 plus 2 root 5. So on top we have root 7 plus 4 times 3 plus 2 root 5. On the bottom, we have 3 minus 2 root 5 times 3 plus 2 root 5. So let's go ahead and multiply those. So root 7 plus 4, 3 plus 2 root 5, root 7 plus 4, 3 plus 2 root 5. 3 times root 7 is 3 root 7. 2 root 5 times root 7 is root 5 times root 7, root 35, 2 root 35. 4 times 3 is just 12. 4 times 2 root 5, 4 times 2 is 8 times root 5 is 8 root 5. So on top, I get adding all this up, and the order doesn't really matter. 3 root 7 plus 2 root 35 plus 12 plus 8 root 5, all over what's on the bottom? Well, I have to do 3 minus 2 root 5 times 3 plus 2 root 5. So let's do that. 3 minus root 5 times 3 minus 2 root 5 times 3 plus 2 root 5. 3 minus 2 root 5, 3 plus 2 root 5. 3 times 3 is 9. 3 times 2 root 5 is positive 6 root 5. 3 times negative 2 root 5 is negative 6 root 5. Positive times negative, 2 times negative 2, negative 4 root 25, which is negative 4 times 5, which is negative 20. So if all this is put together, the 6 root 5 and the negative 6 root 5 go away, and I have 9 plus negative 20. 9 plus negative 20 is negative 11. So on the bottom of all this, we get negative 11. And that's our answer to that problem. So you see the process: multiply top and bottom by the conjugate, do the multiplication, and simplify. Let's do another one. This time I want to do root x plus root y. Remember, we're assuming all the variables are positive, over root x minus root y, which will be root x plus root y over root x minus root y, multiply top and bottom by the conjugate. The conjugate is the bottom, switch the sign in the middle. So the conjugate of the bottom is root x plus root y. So again, on top, we're going to have root x plus root y times root x plus root y. On the bottom, we have root x minus root y times root x plus root y. So these need to be multiplied. On top, we have x plus root x plus root y, root x plus root y. Let's quickly do that. Root x plus root y, root x plus root y. Root x times root x is root x squared, or just x. Root x times root y is plus root xy. Root x times root y is plus root xy. Root y times root y is plus y. So we get what? We get x plus 2 root xy plus y on the top. X plus 2 root xy plus y on the top. On the bottom, I have root x minus y times root x plus y. Let's do that. Root x minus y times root x plus root y. Root x times root x is root x squared, or x. Root x times root y is plus root xy. Root x times negative root root xy. Root y is y, positive, negative, minus y. This goes away. I'm left with x minus y. And that is my answer to that question. So we can see how that multiplication works again. Root x times root x is x. Root x times y is plus root xy. Negative root y times root x. Negative root xy. Negative root y times root y. Negative y. And that will conclude this lesson.